Now, in this lecture, we will find the area of the green shape. In the drawing, we have triangle ABC. We know that angle BAC of triangle ABC, this angle equals to 60 degrees. And we also know that BF equals to CF equals to DF equals to EF, and we also know that triangle BDF, the area of triangle BDF is 8 square units, and the area of triangle FEC, this triangle, is 15 square units, and we want to find out the area of the green shape or green quadrilateral ADFE. So first of all, we will define angle ABC. This angle is B, and we will also define angle ACB as C, and we know that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in the big triangle, triangle ABC, is equal to 180 degrees. That is to say, 60 degrees plus angle B plus angle C must be equal to 180 degrees. Okay, again, the sum of the angles in triangle ABC equals to 180 degrees. Here we will subtract 60 degrees from this equality, from equation number 1, and we will get that B plus C equals to 120 degrees. Okay, so equation number 1 states that B plus C equals to 120 degrees. Okay, actually we have a rule. I will call it rule number 1. Rule number 1 states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 1 again. Rule number 1 states that in front of equal sides in the triangle there are equal angles. So actually, if we focus on triangle BDF, we have side BF that equals to side DF in triangle BDF. We know that BF equals to DF, it is given us in the question. Therefore, according to rule number 1, in front of side BF we have angle BDF, this angle, and in front of side DF in triangle BDF we have angle B. So those two angles are located in front of equal sides, therefore they are equal to each other. So if this angle is B, then this angle also must be equal to B. Okay? And the same thing in triangle FEC. We know that FC equals to FE. FC equals to FE. In front of FE we have angle C, and in front of FC we have angle FEC, this angle. So according to rule number 1, those two angles that are located in front of equal sides in the triangle are equal to each other. So if this angle equals to C, this angle must be equal also to C. Okay? In the next step, we will define angle BFD as P, and we will define angle EFC, this angle as Q. We know that the sum of the angles in the triangle is equal to 180 degrees. Therefore, if you focus a triangle DBF, in triangle DBF, we know that the sum of the angles in triangle DBF is equal to 120 degrees. That is to say, B plus B plus P equals to 180 degrees, or 2B plus P equals to 180 degrees. Okay. Two B plus P equals to 180 degrees. Here we will substitute 2B from this equality, and we will get that P equals to 180 degrees minus 2B, and we also know that the sum of the angles on this triangle FEC is equal to 180 degrees. That is to say, angle C plus angle C plus angle Q equals to 180 degrees. Again, in triangle FEC, we know that 2C plus Q equals to 180 degrees. Here we will subtract 2C from this equality, and we will get that angle Q equals to 180 degrees minus 2C. And we also find out that angle P equals to 180 degrees minus 2B. So here we will add Q to P. So Q plus P, that will be question number 2, Q plus P equals to 180 degrees plus 180 degrees is 360 degrees. Minus 2c plus minus 2b is minus 2b minus 2c. So here we will take a common factor of minus 2 from this expression, and we will get that q plus p equals to 360 degrees minus 2 times b plus c. But we know that b plus c equals to 120 degrees from equation number 1. b plus c equals to 120 degrees. Okay, so we can substitute b plus c in equation number 2 by 120 degrees. So we will get that q plus p equals to 360 degrees minus 2 times p plus c equals to 120 degrees. So actually I found out that q plus p equals to 360 degrees minus 2 times 120 degrees. 2 times 120 degrees is 240 degrees, so I will write it down. So q plus p equals to 360 degrees, and 2 times 120 degrees is 240 degrees. So q plus p equals to 360 degrees minus 240 degrees is 120 degrees. So we found out in equation number 2 that q plus p equals to 120 degrees, and we have already found out in equation number 1 that b plus c also equals to 120 degrees. Okay, q plus p equals to 120 degrees, and b plus c also equals to 120 degrees. So in the next step we will join together points D and E by a straight line. And we will find out the size of angle EFD, this angle, according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. So I read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. So We know that BC is one of the sides of triangle ABC. Therefore, BC is a straight line, and therefore we can implement rule number 2 that says the sum of the angles on a straight line is equal to 180 degrees. And if we focus at point F, we can say that the sum of the angles on the straight line BC at point F must be equal to 180 degrees according to rule number 2. That is to say, P plus Q plus the size of angle DFE must be equal to 180 degrees according to rule number 2. Okay. Again, P plus Q plus the size of angle DFE must be equal to 180 degrees according to rule number 2. That says the sum of the angles on a straight line is equal to 180 degrees. So P plus Q plus the size of angle DFE must be equal to 180 degrees. Okay, but we have already found out that P plus Q equals to 120 degrees. Equation number 2 states that P plus Q equals to 120 degrees. So here we can substitute P plus Q in this equality by 120 degrees. So we'll get that 120 degrees plus angle DFE equals to 180 degrees. So here we will subtract 120 degrees from this equality, and we will get that angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. So the size of this angle is 60 degrees. Angle DFE equals to 60 degrees. Okay. We also know that side DF equals to side FE in triangle DFE. In triangle DFE, the green triangle, we know that side DF equals to side EF. In front of side DF we have angle DEF, and in front of FE we have angle FDE, this angle. So those two angles that are located in front of equal sides in triangle DFE must be also equal to each other. So if we define one angle as Y, then the other angle must be also equal to Y, because those two angles are located in front of equal sides, therefore they are equal to each other. So if this angle is Y, this angle must be equal also to Y. And the sum of the angles in triangle DFE must be equal to 180 degrees, therefore Y plus 60 degrees must be equal to 180 degrees. Okay. 2y plus 60 degrees must be equal to 180 degrees. Here we will substitute from this equality 60 degrees. and we will get that 2y equals to 120 degrees. So here we will divide this equality by 2, and we will get that angle y equals to 60 degrees in its size. Okay, so actually angle y equals to 60 degrees, so we write here 60 degrees, and also this angle y equals to 60 degrees. So actually triangle DFE is an equilateral triangle because it has all its angles are equal to 60 degrees, and we know that in an equilateral triangle all the sides of an equilateral triangle are equal to each other, so this side equals to this side equals to this side, and actually all the sides that I marked with 2 blue lines, those 2 blue lines are equal to each other. Therefore, if we define this side as x, then FC will be also equal to x, and DF also equal to x, will be equal to x, and FE also will be equal to x, and DE will be also equal to x. Okay, in the next step we will find out the sizes of those 2 angles. We will find out the size of angle ADE, and we will also find out the size of angle AED. Okay, again we have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. AB is one of ABC sides, one of the sides of ABC, therefore AB is a straight line, and therefore the sum of the angles on the straight line AB equals to 180 degrees. And if we focus on point D, we can say that the sum of the angles at point D at the straight line AB is equal to 180 degrees. That is to say, angle B plus this angle that equals to 60 degrees plus angle ADE, this angle must be equal to 180 degrees according to rule number 2. Okay, B plus 60 degrees plus angle ADE must be equal to 180 degrees. Here we will subtract 60 degrees and B from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, angle AD equals to 120 degrees minus B, but we have already found out that in equation number 1 that B plus C equals to 120 degrees, and if we subtract from equation number 1 B, we get that C equals to 120 degrees minus B. So according to equation number 1, 120 degrees minus B equals to C. So here we have the equality of 120 degrees minus B according to equation number 1, 120 degrees minus B equals to C. Okay, so from this equality, we can derive that angle ADE equals to C. Okay, angle ADE equals to C. Angle ADE equals to C. So we can write here that angle ADE equals to C. We will repeat on the same process on the other side of triangle ABC. Again, we know that AC is one of ABC sides, therefore AC is a straight line, and we know that the sum of the angles on a straight line is equal to 180 degrees, and if we focus at point E on the straight line AC, the sum of the angles is equal to 180 degrees. That is to say, C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. Again, angle C plus 60 degrees plus the size of angle AED must be equal to 180 degrees according to rule number 2. Here we will subtract 60 degrees and C from this equality, and we will get that angle AED equals to 120 degrees minus 60 degrees is 120 degrees minus C. Okay, but we have already found out that P plus C equals to 120 degrees. Here we will subtract from equation number 1 B, we will subtract from equation number 1 C, and we will get that 120 degrees minus C equals to B. So here 120 degrees minus C equals to B according to equation number 1, and from this equality we can derive that angle AED equals to B. Okay, angle AED equals to B. Angle AED equals to B. Okay, angle AED equals to B. Okay, in the next step we will focus on triangle ABC and on the small triangle ADE. So in triangles ABC, and triangle ADE, we know that angle AED in triangle ADE equals to angle ABC in triangle ABC, and both those two angles are equal to B. Both those two angles are equal to B. And angle ADE in triangle ADE equals to angle ACB in triangle ABC. and both those two angles are equal to C. Okay, so we found out that angle AED in triangle ABC, angle AD in triangle ADE equals to angle ABC in triangle ABC, and it equals to B, and angle ADE in triangle ADE equals to angle ACB, and both those two angles are equal to C. And we also have the third angle. This angle is a common angle. It belongs both to to triangle ADE, and it also belongs to the big triangle, triangle ABE. So angle A equals to angle A. Angle A equals to 60 degrees. Angle A equals to angle A. It is a common angle. It belongs to both triangles. Okay. Angle A equals to angle A. So actually we proved that all the three angles in the big triangle ABC are congruent to all the triangles in triangle ADE. Therefore, triangle ABC is similar to triangle ADE according to angle similarity rule. Read again the place that I wrote. Triangle ABC similar to triangle ADE according to angle similarity rule. Whenever you prove that all the angles of one triangle are congruent to all the angles of another triangle, then those two triangles will be similar to each other according to angle similarity rule. Okay? So we have rule number 3 that relates to similar triangles. According to rule number 3, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So I'll read rule number 3 again. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually Rule number 3 relates to similar triangles. It actually states that the area of triangle ABC that is the way that we mark the area. This means that the area of triangle ABC, so the area of triangle ABC over the area of triangle ADE will be equal, according to rule number 3, that will be equal to the square ratio between the corresponding sides, and the square ratio between the corresponding sides is BC square over DE square. Okay? Again, according to rule number 3, the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. So, what is the value of BC? BC equals to x plus x, that is 2x, so BC square equals to 2x square over DE. DE equals to x and DE square equals to x square. So we got 2x square over x square. 2x square is 4x square. 4x square over x square is 4. So the area of triangle ABC over the area of triangle ADE equals to 4. Okay, so here, if we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. Again, the area of triangle ABC equals to 4 times the area of triangle ADE. But what is the area of quadrilateral BDEC? Actually, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. Okay? Again, the area of quadrilateral DBEC equals to the area of triangle ABC, the big triangle, minus the area of triangle ADE, the small green triangle. Okay? The area of the quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. Okay? The area of triangle ABC equals to 4 times the area of triangle ADE minus 1 time of triangle ADE So 3 times the area of triangle ADE minus 1 time the area of triangle ADE equals to 3 times the area of triangle ADE. So we actually found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE, and the area of triangle ABC equals to 4 times the area of triangle ADE. Okay? So in the next step I will present to you a new formula for the area of any triangle. Actually, if we have triangle ABC, in this triangle ABC, we know that the size of side AB equals to A units, and the size of side AC in triangle ABC equals to B units. And we also know that the angle between side AB and side AC is theta. Then the area of this triangle equals to A times B times sinus theta over 2. Okay, the area of this triangle, triangle ABC, equals to A times B times sin theta over 2. Again, the area of this triangle, triangle ABC, equals to A times B times sin theta over 2. Okay? The area of the big triangle EFD, that is 15 square units, over the area of the small triangle, triangle DBF, that is 8 square units. So we divided the area of the big triangle by the area of the small triangle, and now we will calculate the area of the small triangle and the big triangle according to the formula that I presented to you. So the area of the big triangle EFC will be equal to EF times FC times sine Q over 2. Okay, according to the formula that I presented to you, the area of the big triangle that equals to 15 square units will be equal to EF times FC times sine Q over 2. And the area of the small triangle, according to the formula that I presented to you, will be equal to DF times BF times sine P over 2. Again, the area of the small triangle will be equal to DF times BF times sine P over 2. Okay? Here we will move 2 to the numerator, and DF times BE times sine P to the denominator of this expression, and we will get that 15 over 8 equals to 2 times EF times FC times sine q over 2 times df times vf times sine p. Okay, 15 over 8 equals to this expression. So here 15 over 8, so we can cancel 2. We can cancel 2. 2 over 2 is 1, so we can cancel 2. And what is the value of EP and the value of EF? EF equals to x, FC equals to x, so EF times FC is x squared. And what is the value of DF? DF equals to x, and the value of VF is also x, so DF times VF is x times x, that is x squared. So in total we got that 15 over 8 equals to x squared times sine q over x squared times sine p. So here x squared over x squared is 1, so x squared is cancelled. So we left with sine q over sine p equals to 15 over 8. Okay, so we got this equality that sine q over sine p equals to 15 over 8. Okay, but we have already found out that q plus p equals to 120 degrees. Okay, here we will subtract p from equation number 2, and we will get that q equals to 120 degrees minus p. Okay, q equals to 120 degrees minus p. So here we have sine q. We can substitute q by 120 degrees minus p according to equation number 2. So we'll do it now. Sine q is actually sine 120 degrees minus p over sine p equals to 15 over 8. Okay. In order to find out the value of sine 120 degrees minus p, I present to you a new trigonometric identity, actually for sine a minus b. Sine a minus b equals to sine a times cosine b minus sine b times cosine a. Okay, So we will use this trigonometric identity in order to find out the value of sine 120 degrees minus p. We will get that sine 120 degrees minus p according to this trigonometric identity will be equal to sine p times to sine 120 degrees, sine 120 degrees minus p according to this trigonometric identity will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, so according to this trigonometric identity, that is the value of sine 120 degrees minus p. So actually it equals to sine 120 degrees minus p is root 3 over 2 times cosine p minus sine p. Cosine 120 degrees is minus 1 over 2. Okay, and here we have minus, and minus is plus, so here we will get that it equals to root 3 over 2 times cosine p and minus is plus, so it will be plus 1 over 2 times sine p. So actually we found out that the value of sine 120 degrees minus p according to the trigonometric identity that I presented to you, it equals to root 3 over 2 times cosine p plus 1 over 2 times sine p. So we return to our original identity, that is sine 120 degrees minus p over sine p equals to 15 over 8. So here we will substitute sine 120 degrees minus p by this expression that is equals to sine 120 degrees minus p according to the trigonometric identity that I presented to you. So instead of sine 120 degrees minus p, we write down the expression that equals to sine 120 degrees minus p, that is root 3 over 2 times cosine p, and we must divide sine 120 degrees minus p by sine p, plus 1 over 2 sine p over sine p is actually 1 so cosine p over sine p is cotangent p, plus 1 over 2 equals to 15 over 8. Okay, so here we have trigonometric identity for cotangents P. Actually, cotangents P equals to 1 over tangents P. Again, cotangents P equals to 1 over tangents P. So we will substitute cotangents P by 1 over tangents P. Okay, we will get that root 3 over 2 times tangents P plus 1 over 2. 1 over 2 is 4 over 8 equals to 15 over 8. Okay, here we will substitute 4 over 8 from this equality, and we will get that root 3 over 2 times tangents P equals to 15 over 8 minus 4 over 8 is 11 over 8. Okay, so here we will multiply this equality by tangents P, and we will get that 11 over 8 times tangents P equals to root 3 over 2. Okay, so here we will multiply this equality by 8 and we will divide it by 11 in order to get the value of tangents P. So here tangents P will be equal to root 3 over 2 times 8 divided by 11. So here 8 over 2 is 4. So we actually found out that the value of tangents P is actually 4 times root 3 over 11. Okay. Again, tangents P equals to 4 times root 3 over 11. So actually the function tangents P expresses relationship between the sides of a right triangle. So if we have a right triangle, we know that this side is 4 times root 3, and we also know this is a right angle, and this angle equals to P. It will be 11. So here, this drawing actually expresses the value of tangents P exactly, because here tangents P will be equal to 4 times root 3 over 11, exactly like this expression. So this drawing actually expresses this, the tangent P equals to 4 times root 3 over 11, and we will calculate the value of the hypotenuse of this right triangle according to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually the square of the hypotenuse is 11 square plus 4 times root 3 square. Okay, this expression is the square of the hypotenuse, but we don't want the square of the hypotenuse but the hypotenuse itself. So if we take a root from the square of the hypotenuse, we will get the hypotenuse itself. So the root of the square of the hypotenuse equals to the hypotenuse itself. Okay, and here sinus P equals to 4 times root 3 over the hypotenuse. What is the value of the hypotenuse? It actually equals to the root of 11 square is 121, and 4 times root 3 square is 48, so 48 plus 121 is 169, and the root of 169 is 13. So the value of sinus P is 4 times root 3 over 13. Okay, so we found out the value of sin P. Again, sin P equals to 4 times root 3 over 13. But what is the area of triangle DBF according to the formula that I presented to you? The area actually equals to x times sin P over 2, or x squared times sin P over 2. Okay, actually that is the area of triangle DBF, x squared times sin P over 2. But we know that the area of triangle DBF equals to 8, so we can write that it is actually equal to 8 square units. And we have already found out that sin P equals to 4 times root 3 over 13, so we can substitute sin P by 4 times root 3 over 13. So we get that x squared over 2 equals to 4 times root 3 over 13, that equals to 8. Okay, here 4 over 2 is 2, so we can write down that 2 times root 3 over 13 x squared equals to 8. So here we will divide this equality by 2, and we will get that root 3 over 13 times x squared equals to 4. Okay, so here we will multiply this equality by 4, and then we will divide it by root 3, and we will get that x squared equals to 13 times 4 is 52 over root 3. So we found out that x squared equals to 52 over root 3. But what is the area of the equilateral triangle DFE, the area of this equilateral triangle, equals to x times x, that is x squared, times sine 60 degrees over 2. Sine 60 degrees is root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. So the area of the equilateral triangle, triangle DFE, equals to x squared times root 3 over 4. Okay, the area of the equilateral triangle, triangle DFE, equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over 3. So we can substitute x squared in this equality by 52 over 3. 52 over root 3. Okay, we will get that the area of triangle DFE equals to x squared is 52 over root 3 times root 3 over 4. Here root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of triangle DFE equals to 13 square units. So the area of triangle DFE, the equilateral triangle, triangle DFE, equals to 13 square units. So now we can find out the area of quadrilateral DBEC. The area of quadrilateral DBEC will be equal to the area of triangle DBF, that is 8 square units, plus the area of the equilateral triangle, triangle DFE, that is 13 square units, plus the area of triangle EFC, that is 15 square units. So in total we found out that the area of quadrilateral DBEC equals to 13, 8 plus 13 is 21, and 21 plus 15 is 36. Okay. Again, the area of quadrilateral DBFC equals to 13 square units. The area of quadrilateral DBFC equals to 13 square units. But we have already found out that the area of quadrilateral DBFC actually it's 36. We found out that the area of quadrilateral DBEC, the area of quadrilateral DBEC equals to 36 square units. The area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE. Okay, we found out that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE. And we also know that the area of triangle DBEC equals to 36 square units. Okay, so actually from this equality we can derive that 3 times the area of triangle ADE equals to 36, okay? Here we will divide this equality by 3 and we will get that the area of triangle ADE equals to 36 over 3 is 12 square units. So the area of triangle ADE equals to 12 square units. So the area of the green shape will be equal to the sum of those two triangles, or the area of quadrilateral ADEC, ADEF, the area of quadrilateral ADEF will be equal to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle DEF, that is 13 square units. In total is 25. So the area of quadrilateral ADEF equals to 25 square units. Okay, the area of quadrilateral ADEF equals to 25 square units. The area of this quadrilateral ADEF equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green shape. We know that the angle ABC of triangle ABC equals to 60 degrees, and we also know that BF equals to CF equals to DF equals to EF, and we also know that triangle the size, the area of triangle BDF is 8 square units, and the area of the big triangle, triangle CEF, is 15 square units. And we want to find out the area of the green shape ADEF. Okay. So actually we defined angle ABC as B and angle ACB as C, and we know that the sum of the angles in any triangle equals to 180 degrees, therefore 60 degrees plus B plus C equals to 180 degrees. 60 degrees plus B plus C equals to 180 degrees. We subtracted from equation number 1 60 degrees, and we found out that B plus C equals to 120 degrees. Then we have rule number 1 that says that in front of equal sides in the triangle there are equal angles. So actually in triangle BDF, we know that BF equals to DF. Now, those two sides, those two angles are located in front of equal sides. Therefore, they are equal to each other. So, if this angle is B, this angle is also B. And the same thing is about triangle EFC. We know that EF equals to FC, and in front of EF we have angle C, and in front of FC we have this angle. So those two angles are located in front of equal sides in the triangle, therefore they are equal to each other according to rule number 1. So if this angle is C, this angle also must be equal to C. Okay, then we define the angle DFB as P. and we define the angle EFC as Q. Okay, and again in triangle DBF, the sum of the angles equals to 180 degrees, that is to say B plus B, that is 2B plus B, equals to 180 degrees. Okay, 2B in triangle DBF, 2B plus B equals to 180 degrees. We subtracted 2B from this equality and we got that B equals to 120 degrees minus 2B. And the same thing in triangle EFC, we know that C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. We subtracted 2C from this equality and we got that Q equals to 180 degrees minus 2C. And we have already found out that P equals to 180 degrees minus 2B. So we add Q to P and we found out that Q plus P equals to 130 degrees plus 120 degrees is 360 degrees. Minus 2C plus minus 2B is minus 2B minus 2C. Then we take a common factor of minus 2 from this expression and we got that Q plus P equals to 360 degrees minus B plus C, but we have already found out that according to equation number 1 that B plus C equals to 120 degrees, so we can substitute B plus C in equation number 2 by 120 degrees. Okay? And we got that Q plus P equals to 360 degrees minus 2 times 120 degrees. 2 times 120 degrees is 240 degrees. And here 360 degrees minus 240 degrees is 120 degrees. So we found out that Q plus P equals to 120 degrees, and we have already found out that B plus C equals to 120 degrees. And also we have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. So we know that BC is one of the sides of triangle ABC, therefore it is a straight line. So we can implement rule number 2 on the straight line BC. According to rule number 2, the sum of the angles at the straight line BC is equal to 120 degrees. That is to say P plus Q plus angle DFE must be equal to 180 degrees. Okay? P plus Q plus angle DFE must be equal to 180 degrees, but we have already know that P plus Q equals to 120 degrees, so we can substitute P plus Q by 120 degrees according to question number 2. So we substituted P plus Q by 120 degrees and we got that the size of angle DFE, this angle is equal to 60 degrees. Okay? Then we connected together points D and E by a straight line, and we focus on the triangle DEF or DFE. We know that DF equals to DE. Therefore, according to rule number 1, in front of equal sides there are equal angles. So those two angles that are located in front of equal sides are also must be equal to each other. So if this angle is y, this angle also must be equal to y, because those two angles are equal to each other. So in triangle DFE we get that 2y, y plus y is 2y plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equality and we got that 2y equals to 120 degrees. We divided this equality by 2 and we found out that y equals to 60 degrees. Okay, so this angle equals to 60 degrees and this angle y also equals to 60 degrees. So actually triangle DFE is an equilateral triangle. That is to say, all of its sides are equal to each other. So if this side is x, this side is also x, and this side is also x, and all the lines that all the sides that I marked with two blue lines are equal to each other, so this is also x and FC also equals to x. Okay, and then we found those two angles according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. So AC is a straight line, therefore B or we focus on AD, on AB is a straight line, therefore B plus 60 degrees plus the size of this angle ADE equals to 180 degrees according to rule number 2. So B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. We subtracted B and 60 degrees from this equality, and we got that AD equals to 120 degrees minus B. But we already know that B plus C equals to 120 degrees, so we can substitute. Here we subtracted B from equation number 1, and we got that C equals 120 degrees minus B equals to C. So here 120 degrees minus B equals to C according to equation number 1, and from this equality we got that angle ADE equals to C. Okay, angle ADE equals to C. Then we repeated on the same process on AC. AC is a straight line, therefore the sum of its angles is equal to 180 degrees. That is to say, C plus 60 degrees plus angle AD equals to 120 degrees. Again, C plus 60 degrees plus angle AD equals to 180 degrees according to rule number 2. We subtracted C and 60 degrees from this equality, and we got that the angle AED equals to 120 degrees minus C. But we know that B plus C equals to 120 degrees. So if we subtract C from equation number 1, we will get that B equals to 120 degrees minus C. So here 120 degrees minus C equals to B according to equation number 1. So from this equality we can derive that angle AED equals to B. Okay, this angle AED equals to B. Then we focused on triangle ABC and triangle ADE. Actually we proved that those two triangles are similar to each other. Actually the small triangle ADE has angles B, C and 60 degrees, and the big triangle ABC also has angles of B, C and 60 degrees. Therefore those two triangles are similar to each other because they have the same angles. And we have rule number 3 that states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. That is to say, the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. And BC square over DE square is 4, so the area of triangle ABC over the area of triangle ADE equals to 4, or the area of triangle ABC equals to 4 times the area of triangle ADE. And then we found out the area of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle AED. Okay, the area of triangle ABC minus the area of triangle AED, but we've already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So we found out that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE, and we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Then I presented to you a new formula for the area of any triangle. The area of this triangle equals to A times B times sinus theta over 2. Then we divided the area of the big triangle, that is 15 square units, by the area of the small triangle, that is 8 square units, and we calculated the area of those two triangles according to the formula that I presented to you, and we found out that sine Q over sine P equals to 15 over 8, but we already know that Q plus P equals to 120 degrees, so Q equals to 120 degrees minus P, so we substituted Q by 120 degrees minus P. As we solved this equality by the trigonometric identity of sine A minus B, and we found out that tangents P equals to 4 times root 3 over 11, and sinus P equals to 4 times root 3 over 13. Okay, and sine P equals to 4 times root 3 over 13. We calculated the area of the small triangle, triangle DBF, according to the formula that I presented to you. So we substituted sinus P by 4 times root 3 over 13, and we found out that x squared equals to 52 over root 3. Okay, then we calculated the area of equilateral triangle DFE. Actually it equals to x squared times root 3 over 4. So the area of triangle DFE is 13 square units, and the area of quadrilateral DBEC equals to 36 square units, but we have already found out that the area of equilateral DBEC equals to 3 times the area of triangle ADE. So from this equality we can derive that 3 times the area of triangle ADE equals to 36. We divided this equality by 3, and we found out that the area of triangle AD equals to 12 square units. So the area of quadrilateral ADEF equals to the area of triangle ADE, that is 13 square units, plus the area of triangle DEF, that is 13 square units. So the total area of quadrilateral ADEF equals to the sum of those two, to the sum of the areas of those two triangles. That is to say, it equals to 12 plus 13. That is to say, the area of quadrilateral ADEF equals to 25 square units. Okay, again, I will repeat that the area of quadrilateral ADEF equals to the sum of the areas of those two triangles. That is to say, it equals to 12 square units plus 14 square units, or the area of quadrilateral ADEF equals to 25 square units. Okay, the area of the green shape of the equilateral ADEF equals to 25 square units. Okay, thank you very much.